The Earth is the only planet known to man that supports life. A variety of plants and animals live on our planet. Natural resources available on Earth influence all life forms. In this lesson, you will learn about natural resources such as air, water, and soil, their importance, and the pollution of these resources. By the end of this lesson, you will be able to describe Earth as a biosphere, describe air as a natural resource, describe the role of air in control of climate, list the causes of air pollution, describe water as a natural resource, list the causes of water pollution, describe soil as a natural resource, describe the formation of soil, and list the causes of soil pollution.
Hi there! How are you doing today? I'm here to join you on an exciting ride to learn something more about the place we live in, Earth, and its resources. So gear up, 'cause it's time to take off. Do you know the 3 important natural resources of Earth? I don't. So let's find out.
The resources available on Earth are land, water, and air. The solid outermost layer of the Earth's crust and the rigid upper part of its mantle is called lithosphere. The water that is found on the Earth's surface, above it as clouds, and below it as groundwater, is called hydrosphere. It constitutes 75% of the Earth's surface. The air that covers Earth like a blanket is called the atmosphere. The region of Earth where the atmosphere, hydrosphere, and lithosphere interact and support life is called the biosphere.
Wow! I didn't know that. But I know what bio means. Bio means life. Let's find out more.
The biosphere has 2 components, biotic and abiotic. Living organisms constitute the biotic component of the biosphere. Air, water, and soil constitute the abiotic component of the biosphere.
Okay. So that means the biotic and abiotic components need each other, right? Living organisms need air, water, and soil to live.
The biotic component utilizes natural resources like land, water, and air to survive. Let's look at air as a natural resource. Air is a mixture of gases like nitrogen, oxygen, carbon dioxide, and water vapor, which support life. Let's now focus on the atmospheric gases that are used on Earth, like nitrogen, oxygen, and carbon dioxide. Nitrogen is used to produce a number of organic molecules like proteins. Nitrogen is fixed in plants and is transferred to animals through the food chain. Plants and animals use oxygen for respiration. Combustion of fossil fuels also requires oxygen. The other important atmospheric gas, carbon dioxide, is mainly used by green plants for photosynthesis to prepare food. Marine animals absorb atmospheric carbon dioxide and form carbonic acid. These carbonate ions are used by marine animals to make shells.
I couldn't live without oxygen or carbon dioxide. I'm sure there is more that air does for us.
That's right. Air helps to maintain a steady temperature on Earth during the day and controls the climate and the formation of rain. Let's see how. Here are 3 beakers. The first is filled with water, the second with soil, and the third is left empty. A thermometer is placed in each of the beakers. The beakers are placed in sunlight for 3 hours and the thermometer readings are taken. Do you notice a difference in the readings? The temperature reads more in the second beaker than in the others. This indicates that soil gets heated faster than water and air. If we perform the same experiment under shade, this is how the temperature stands. This time, the temperature reads more in the first beaker than in the others. This indicates that soil gets cooled faster than water and air. Since soil gets heated faster than water, the air above land also gets heated faster than the air above water bodies. During the day, heated air above the land starts rising, creating a low-pressure area. This causes air to move from a high-pressure area over the sea to a low-pressure area over the land. This creates a sea breeze. This is the reason why land near water bodies gets colder faster.
Cool! That's why I like the seaside best. But if all this happens in the day, what happens at night?
At night, since soil cools faster than water, the air above the land is cooler than the air above the sea. This causes air to move from a high-pressure area over the land to a low-pressure area over the sea, creating a land breeze. However, it is not only the temperature, but some other factors that are equally important, like rotation of the earth, presence of mountains, altitude, etc. Apart from causing land and sea breezes, air also helps to form rain. Let's see how. Water bodies get heated during the day and water evaporates into the air. Hot air rises and carries the water vapor with it. As the air rises, it cools. This causes the vapor to condense into tiny water droplets. When these droplets grow bigger, they fall down as rain. This process is called precipitation. When the temperature is low, precipitation may occur in the form of snow, sleet, or hail. In many parts of India, rain is brought by seasonal winds called monsoons. There are 2 types of monsoons, southwest and northeast. Southwest monsoons brings the maximum amount of rainfall for India.
Look at what I got for you. This map shows the rainfall pattern of India. These regions in India receive high rainfall and show maximum biodiversity. These regions have moderate rainfall, while these areas receive low rainfall and show minimum biodiversity.
The contamination of air with chemicals, smoke, dust particles, and disease-causing agents is called air pollution.
No wonder I have been coughing all day. We should stop polluting the air. But before that, let's find out the causes.
Burning of fossil fuels contributes to the addition of suspended, unburnt hydrocarbon particles into the air. Fuels like coal and petroleum also release nitrogen and sulfur oxides. These oxides of nitrogen and sulfur dissolve in air and form acid rain. Breathing of this polluted air causes allergies, cancer, and heart diseases. Now, let us look at another natural resource, water. It is found on the Earth's surface, under the ground, and in the atmosphere as water vapor. Most of the water on the Earth's surface, found in seas and oceans, is saline. Fresh water is found frozen at the two poles, on snow-covered mountains, and in rivers and lakes. The availability of water is one of the main factors that decide the nature of vegetation and diversity of life in an area. Water is essential for the survival of plants and animals, as cellular processes take place in a water medium. The contamination of water by sewage, chemicals, detergents, fertilizers, and other harmful substances is called water pollution. Let's take a look at the causes of water pollution. Industry chemicals and urban sewage are dumped into rivers and lakes. Fertilizers and pesticides used in farms dissolve in water. Dissolved oxygen is needed by aquatic animals. A rise in the water temperature removes the dissolved oxygen and causes the death of many aquatic animals.
Look at what we have done again. Very soon, there'll be no clean water to drink.
Like air and water, soil is another important natural resource that supports life. You must have seen different types of soil, but do you know what it really is? Soil contains soil particles, humus, and living organisms. Humus determines the quality of soil. Over millions of years, rocks on the Earth's crust have been broken down by physical, chemical, and biological processes to make soil. Sun, water, wind, and living organisms are the factors that help in the making of soil. Due to uneven contraction and expansion, rocks crack and break into smaller particles of soil. Water logged in the cracks of rocks freezes, and the cracks widen to eventually break into soil. Living organisms like lichens grow on the surface of rocks and release chemicals that powder rocks to soil. The flowing water in rivers breaks the hard rock and forms soil particles. Strong winds erode rocks and carry sand from one place to another. The addition of substances that adversely affect soil fertility is called soil pollution.
It seems we didn't spare soil too. How did we do it?
Use of fertilizers and pesticides destroy soil structure by killing microorganisms and earthworms. Deforestation leads to soil erosion. Fine particles of soil are also carried away by water and wind.
Soil forms very slowly. Around 1 centimeter of soil is formed in 500 years. So it is important to conserve soil.
What comes first, the nut or the tree? That may be a tough call to take. Whether it's the seasons or life on Earth, nature works in cycles. In this lesson, you will learn about biogeochemical cycles, the greenhouse effect, and the ozone layer. By the end of this lesson, you will be able to define biogeochemical cycle, describe the water cycle, describe the carbon cycle, describe the nitrogen cycle, describe the oxygen cycle, explain the greenhouse effect, describe the ozone layer, and explain the consequences of the depletion of the ozone layer. The cycling of chemicals between the biological and the geological world is called biogeochemical cycle. The biotic and abiotic components of the biosphere constantly interact through these cycles. During these interactions, there is a transfer of nutrients between living organisms or bio and non-living environment or geo.
Hi there, I'm Oxy. I shall join you on this journey to explore the different biogeochemical cycles. Do you know the 4 most important biogeochemical cycles? They are the water, nitrogen, carbon, and oxygen cycles. We know that water evaporates from water bodies. But have you ever seen seas and oceans drying up? Well, they never do, thanks to the water cycle. Let's see how.
Water evaporates from the water bodies and returns as rain, which in turn flows back into the seas via rivers. This cycle of water between the land, the ocean, and the atmosphere is called the water cycle. Let's take a closer look at the cycle. When the oceans are heated during the day, water enters the atmosphere as water vapor by the process of evaporation. There is another way in which water evaporates into the atmosphere. This happens through transpiration. Water from plants evaporates as vapor into the atmosphere through stoma in the leaves and stems. This water vapor in the atmosphere changes to water droplets and collects to form clouds. This process is called condensation. Sea breeze moves these clouds and carries them over the land, where they break into rain, snow, or fog. This is called precipitation.
Wow, it's raining here. Do you know what happens to the rainwater now? Where does it go?
Much of the rainwater flows into the water bodies and eventually runs off into the ocean. Some of it penetrates the Earth's surface and is logged as groundwater.
Now I get it. This is how water is maintained in the biosphere by the water cycle. Hey, do you know what this is? It's a diamond. Do you know what it's made of? A diamond is made of an element called carbon. Carbon is found in various forms on the Earth. It is present in the atmosphere as carbon dioxide and is an essential part of carbohydrates, fats, proteins, nucleic acids, and vitamins. As you can guess, it's important to maintain the correct amount of carbon in the biosphere. This happens through the carbon cycle.
Let us now look at the carbon cycle in detail. The cycle starts in plants. Plants, in the presence of sunlight, use carbon dioxide in the atmosphere and convert it to carbohydrates through photosynthesis.
Wondering what happens to the carbohydrates? Well, all plants and animals break down carbohydrates for energy and release carbon dioxide through respiration.
Dead plants and animals are decomposed by fungi and bacteria. This decomposition releases the carbon in the remains as carbon dioxide. Dead plant and animal remains in the soil are converted into coal, petroleum, and natural gas, better known as fossil fuels. These fuels are used for cooking, transportation, and industrial processes. On burning these fuels, carbon dioxide is released into the atmosphere. That is how the biological and the geological worlds come together to maintain the carbon balance in the biosphere. Let's now look at an element that makes up 78% of the atmospheric air. Nitrogen is an essential constituent of proteins, nucleic acids like DNA and RNA, vitamins and chlorophyll. This makes nitrogen an essential nutrient for all life forms. Interestingly, most living organisms cannot use nitrogen directly. So, it needs to be converted into usable forms by fixation, either biologically or physically.
Here are some legumes. Do you know what these are? These are nothing but pulses that you should regularly have. They're an important part of the nitrogen cycle. Let's see how.
Legumes have nitrogen-fixing bacteria in their root nodules. These bacteria convert atmospheric nitrogen into ammonia, which is readily utilized by the plants. Nitrogen-fixing bacteria, along with free-living bacteria in the soil, achieve 90% of nitrogen fixation.
That was the biological process of nitrogen fixation. Did you know that lightning plays an important role in nitrogen fixation? Surprised? Let's see how.
When lightning occurs, the high temperature and pressure combine nitrogen and water to form nitrates and nitrites. These compounds dissolve in water and are readily used by plants. Now that nitrogen is taken up by the plants, it is used to make proteins. Once the plants and animals die, the bacteria in the soil decompose the organic matter and release ammonia into the soil. This process is called ammonification. Thereafter, through biological oxidation, ammonia is converted to nitrite and nitrite to nitrate by bacteria in the soil. This process is called nitrification. The nitrite and nitrate are finally converted to gaseous nitrogen by denitrifying bacteria.
Here's the cycle once again for you.
The nitrogen cycle is the sequence in which nitrogen passes from the atmosphere to the soil and organisms and then is eventually released back into the atmosphere.
Now let's take a look at the cycle I like most, the oxygen cycle.
Oxygen makes up 21% of the air and is an essential constituent of carbohydrates, proteins, fats, and nucleic acids. Oxygen is found in air, in the combined form as carbon dioxide, and in the Earth's crust as carbonates, sulfates, and nitrates.
Here's a detailed look at how the cycle works.
Plants and animals use atmospheric oxygen during respiration. Fossil fuels like coal and wood need atmospheric oxygen for combustion.
We have seen how oxygen is used from the atmosphere. Can you think of a way in which oxygen is returned to the atmosphere? Take a look. As you know, oxygen is returned to the atmosphere by photosynthesis in plants. Here's another look at the oxygen cycle.
The sequence in which oxygen from the atmosphere is used by the organisms and eventually released into the atmosphere is called the oxygen cycle.
We have already seen how biogeochemical cycles maintain balance in the biosphere. There are other processes that stabilize temperature on the Earth. Let's explore this a little. Can you guess where I am? It's a greenhouse. Here's how it works. Heat is trapped by glass. Hence, the temperature inside a glass house is much higher than the surroundings. Such enclosures are called greenhouses. You must be wondering, what greenhouses have to do with the biosphere? Take a look.
Solar radiation reaching the Earth is reflected back into the atmosphere. Although much of this radiant heat is lost to space, atmospheric gases like carbon dioxide trap the heat. This is called the greenhouse effect. It keeps the Earth warm to sustain life.
Hi, buddy. Meet my good friend Ozone. He lives in the upper layer of the atmosphere, known as the stratosphere. Atmospheric oxygen contains 2 oxygen atoms, while the ozone has 3. The ozone absorbs harmful ultraviolet radiations from the sun. This prevents the radiations from reaching the Earth's surface, where they might damage life forms. Here's a disturbing fact for all of us. Recent discoveries have revealed that the ozone layer is depleting due to an increase in man-made compounds like chlorofluorocarbons. These are carbon compounds having both chlorine and fluorine. the consequences of the vanishing ozone layer could be dangerous in the future.